Hi, welcome back. So today you're going to learn simplifying cube roots, but before we do that, I want you to practice simplifying some square roots first. So this first one, what I want you to do is I want you to use the method where you're pulling out perfect squares. So do that method for this one. This one, I want you to use the method before you start multiplying them together. I want you to use that method where you're trying to find the common factors that they have in common and pulling those out. So this would be what we learned the day after we learned this method. Go ahead and stop the video, try the two, and when you're done with those two, tune back in. So here are the correct answers for these two problems. I did both of these problems in what I consider the fastest way possible, where we just did it all pretty much in one step. So let me explain. For this one, the perfect square that goes into 63 is 9, so I broke that into 9 times 7. A to the 8th was already a perfect square, so I just left it alone to start with. B to the 13th, I had to break into B to the 12th times B. Then the three things that I circled are my perfect squares, so I pulled out the square root of 9, which is 3, the square root of A to the 8th, which is A to the 4th, and the square root of B to the 12th, which is B to the 6th. What was left on the inside was 7B. If you didn't get this answer, take a closer look at your work and my work, see if you can figure out what you did wrong. On this one, yes, you could have just multiplied the whole thing together, but if you multiply 110 times 55, that's going to give you a pretty big number. So what I did is before I multiplied 110 times 55 together, I decided to see, is there a number that goes into 110 that also goes into 55? Now, many of you might have started with 5, but I went ahead and I was just like, it looks like 110 is going to go into 55, so 110 divided by 2 does give me 55. So what I did is I broke 110 into 2 times 55, and then I have this other 55. So the perfect square here is whatever 55 times 55 is. But since I have two of the same number inside the radical, I can pull that out. Remember, the square root of 55 times the square root of 55, that is just 55. And that's how I got the 55 on the outside. Now with the variables, I think it's just easiest to just multiply the variables together. If you're left with an even number, well then that's a perfect square. If you're left with an odd number, then you should split it up. So the square root of w to the 28th is w to the 14th. Now, if you started this problem by breaking it in with 5s, then look at your final answer. You could have also done 11s. Look at your final answer. Make sure that your radicand is fully simplified. So if you got this one wrong, oftentimes it's because this guy needs to go further. So now we're going to start simplifying cube roots instead of square roots. So the first condition for square roots for a square root radical to be simplified is when the radicand contains no factors that are perfect squares. The same rule applies for a cube root. So if you see here, a cube root radical is simplified when the radicand contains no factors that are perfect cubes. So let's really quickly take a moment, stop the video, fill out what your perfect cubes are. So go ahead and fill out this chart, and notice I threw in some negatives there because remember, negative numbers can also be perfect cubes. Stop the video, fill out your perfect cubes. So double check to make sure that you've got your perfect cubes correct. So you may not have realized yet that negative perfect squares exist. So quick reminder that perfect squares cannot be negative, but perfect cubes can be negative because we're multiplying the negative 3 times. So anytime you have an odd power, you can get a result with negative answer. So let's take these. We haven't quite done these before. So if I asked you to find the cube root of negative 512, well, since negative 8 cubed is negative 512, then the cube root of negative 512 is just negative 8. If I ask you for the cube root of negative 64, well, what I'm asking for is what number to the third power gives me negative 64? Well, that's just going to be negative 4. Okay, so anytime you're asked to find a cube root of a negative number, that just means that the result of it is negative. So now let's go ahead and simplify some of these. So let's start with the cube root of 56. Now, the cube root of 56 is not a perfect cube, but just like we were doing with square roots, we're going to look at our list of perfect cubes. So you're looking at the positive list, and you want to take 56 and you want to start asking yourself what perfect cube goes into 56. and it's 8, right? So you could break up the square root of 50, or the cube root of 56 into the cube root of 8 times 7. And so then what I'm going to do is I'm going to circle my perfect cube, and the cube root of 8 will come out, and the cube root of 8 is 2. So my final answer here is 2 cube root of 7. So the big thing, don't forget to put the little 3 for the cube root symbol. And remember, you're finding the cube roots, not the square roots. So the next one, the cube root of negative 448. Go ahead and start taking that number and dividing it by your perfect cubes. Now because it's negative, your perfect cube that you're going to use is going to be a negative number. So in my division, I just divided negative 448 by 64, but I'm going to use negative 64 because I want to pull out that negative sign. So negative 448 can be broken up into negative 64 times 7. And so negative 64 is my perfect cube. Forgot my little 3. And the cube root of negative 64 is negative 4. What's on the inside is cube root of 7. You never want to leave a negative inside the cube root symbol because negative 1 goes into everything. So now that you've seen me do 2 of the problems, stop the video and try questions 3 and 4 on your own. So for number 3, you should have gotten 4 cube root of 10, and for number 4, you should have gotten negative 5 cube root of 5. If you're at all stuck, look at your work, see if you can figure it out. If you're still stuck, make sure you stop the video and ask for some help. Alright, so just like when we were doing square roots, we had variables, we're going to do the same thing with cube roots. So before we decide how to do that, let's think about which ones of these variables are going to be perfect cubes. Think about it. Which ones can you write as a product of 3 identical factors? So a reminder, let's just take the number 8. The reason the number 8 is a perfect cube is because 2 times 2 times 2 is 8. You have 3 of them, not 2 of them, right? So if you think about variables, well, the ones that you're going to be able to write using 3 identical factors, well, let's start with x to the 3rd, because you could write that as x times x times x. So now thinking about that, which ones do you think you could do as well? So if you thought x to the 6th, that's correct, because you could do that as x to the 2nd times x to the 2nd times x to the 2nd, right? Because remember, you're adding the exponents. X squared times x squared times x squared, you just add the exponents. So the next one would be x to the 9th. So remember, that could be x to the 3rd times x to the 3rd times x to the 3rd. And so from this list, these are the ones that are my perfect cubes. If I wanted to add x to the 12th on here, x to the 12th would also be a perfect cube. So now take a look at your exponents. What can you conclude? Well, you probably already noticed that a variable raised to a power that is a multiple of 3 is a perfect cube. All of these exponents that I circled here are all divisible by 3. So we're going to write they are multiples, they're a multiple of 3. And then if you're going to find the cube root of these, just like with square roots, we divided the exponent by 2. Well, with cube roots, you're going to divide the exponent by 3. So to find the cube root, you divide the exponent by 3. All right, let's try a few. Let's go ahead and look at all of these cube roots at the same time. I'm going to start by circling the ones that I know are perfect cubes. Remember, the ones that have exponents that are multiples of 3. So the cube root of x to the 3rd is a perfect cube. So the cube root of x to the 3rd is just going to be x, right? Because x times x times x is x cubed. Or you can just say, I'm going to divide the exponent by 3. All right? The next one would be the cube root of x to the 6th, right? You just divide the exponent by 2 and you get x to the 2nd. And then the next one I see is the cube root of x to the 9th. The cube root of x to the 9th would just be x to the 3rd, because you just divide the exponent by 3. So the next one I see is the cube root of x to the 18th, because 18 is divisible by 3, so we're going to break that into x to the 6th, because x to the 6th times x to the 6th times x to the 6th is going to give us x to the 18th, where all we're doing is dividing the exponent by 3. Now, none of the other ones have variables that are divisible by 3, but that does not mean that they are already simplified. We have to break them up. So let's take a look at the cube root of x squared, back to the very beginning. That one, you can only break that into x times x. That one is already simplified. So this one is simplified because your exponent is 2. So anything inside the radical that has an exponent of 2 or 1 just stays inside the radical. Now the next one, the cube root of x to the 4th. What we're going to do, just like we did with square roots, is we're going to leave some in. But with cube roots, we can either leave 1 in or we can leave 2 in. So we're going to think backwards. So starting with x to the 4th, if I go backwards 1, I have x to the 3rd. Well, that's divisible by 3. So I'm going to break this into x to the 3rd times x. So the cube root of x to the 3rd is x, I forget the little cube root symbol, and I'm left with the cube root of x on the inside. Now the cube root of x to the 5th, well, I'm going to go back 1 and I'm left with x to the 4th. If I go back 2, I have x to the 3rd. So x to the 5th, when I break that up, is going to be the cube root of x to the 3rd times x squared. And then I find the cube root of x to the 3rd, which is just x, and this time I'm left with the cube root of x squared on the inside. So we found the cube root of x to the 6th is x squared. So now let's take x to the 7th. Well, let's go back 1. You get x to the 6th. So I'm going to break this into the cube root of x to the 6th times x, and the cube root of x to the 6th is going to be x to the 2nd cube root of x. And that's my answer for that one. The cube root of x to the 8th. 8 is not divisible by 3, so we go back 1, we have 7. 7's not. We go back 2, we have 6. 6 is. So I'm going to break this into the cube root of x to the 6th times x to the 2nd. The cube root of x to the 6th is x to the 2nd, and we're left with the cube root of x to the 2nd on the inside. So if you take a look, all the ones that are not divisible by 3, you're either leaving 1x on the inside or you're leaving an x squared on the inside. So take a minute, stop the video, and see if you can try the last 3. So the way to do the cube root of x to the 25th would be to break it into the cube root of x to the 24th times x. And the x to the 24th, that exponent's divisible by 3, so you would get x to the 8th cube root of x. Now the next one, you have to go back 2, so it would be the cube root of x to the 60th times x to the 2nd. The cube root of x to the 60th is x to the 20th, because you're just dividing 60 by 2, and you're left with the cube root of x to the 2nd. Now jumping on over to the cube root of x to the 81st, I'm now just realizing 81 is actually divisible by 3. I forgot about that. Remember, there's a divisibility rule for 3 where you add up the digits, and if the sum of the digits is divisible by 3, so is that number. So 8 plus 1 is 9. 9 is divisible by 3, so 81 must be divisible by 3. And we've played around with 81 quite enough to know that 81 divided by 3 would be 27. So this one, sorry if I confused you, would be x to the 27th. So these are our final answers on those last ones. If you are confused, stop and get some help. Let's move on. So now, just like with square roots, we're going to have numbers and variables all together in the same problem. So let's do 3 together, and then I'm going to let you do the rest on your own. So now I'm going to do the cube root of 54x to the 6th. Just like with square roots, I'm going to take each thing. Is 54 a perfect cube? It's not, but 54 is divisible by 27. So 27 is the perfect cube that goes into 54. So I'm going to break that into 27 times 2. And x to the 6th is already a perfect cube because the exponent is divisible by 3. So now I'm going to circle my perfect cubes, which are 27 and x to the 6th, and I'm going to pull those out. So the cube root of 27 is 3. The cube root of x to the 6th is x to the 2nd because I'm dividing the exponent by 2. And I'm left with, on the inside, the cube root of 2. So now the next one. So negative 432, we're going to look at all of my perfect cubes, and I'm going to start dividing 432 by my perfect cubes. So I tried 27, it works, and then I got 16 back, and then I was like, wait a second, 8 goes into 16, so there must be a bigger one. So then I did 27 times 8, I got 216. So when you have numbers that are pretty big, like 432, I would start with some of the bigger perfect cubes. So 216 is the one. And because it's negative, you're going to pull out the negative. So we're going to say negative 216 times 2. X to the 12th is already a perfect cube because its exponent is divisible by 3. And y to the 5th is not. So I'm going to start thinking backwards. I'm going to go back 1 is 4, go back 2 is 3, and 3 is the 1. So I'm going to break up y into y to the 3rd times y to the 2nd. And now I'm going to circle my perfect cubes. So negative 216 is a perfect cube, x to the 12th is a perfect cube, y to the 3rd is a perfect cube. And I'm going to pull out the cube roots of those. So the cube root of negative 216 is negative 6. The cube root of x to the 12th is x to the 4th, because you're dividing the exponent by 3. The cube root of y to the 3rd is y. And you're left with, on the inside, the cube root of 2y squared. All right, if you really feel like you have it, go ahead and try number 7 on your own. If you don't think you have it, stay tuned to the video. I will explain it. So again, when I took 1,296 and started dividing them, I started with some of my bigger ones, and I found again that 216 goes into it. So I'm going to break that into 216. It goes in 6 times. So it's 216 times 6. And then x to the 30th. Well, 30 is divisible by 3, so I'm going to leave this as x to the 30th, but y to the 31st is not, so I'm going to break that into y to the 30th times y. And so now my perfect squares are my perfect cubes, x to the 30th, y to the 30th. So the cube root of 216 is 6. The cube root of x to the 30th and y to the 30th is going to give me x to the 10th, y to the 10th, and what I'm left with on the inside is the cube root of 6y. So now I would like you to try 8, 9, and 10 completely on your own. So a little piece of advice, again, when you're doing these problems, you should be looking at what your perfect cubes are, and you're only dividing these numbers by your perfect cubes. So stop the video, try 8, 9, and 10. When you're finished, tune back in, make sure you've done them correctly. Alright, so go ahead and take a look at your answers, see if you got them right. I'm going to go through and just kind of circle my perfect cubes. Number 8, we never really pulled out a 1 before, but you do have to pull out the cube root of negative 1, which is 1. I pulled out the cube root of a to the 15th. I pulled out the cube root of b to the 9th. And then when I pulled out the cube root of negative 1, you can just write a negative 1 on the outside, but it really just means that the outside is negative. Number 9, negative 343 was already a perfect cube. M to the 6th was already a perfect cube. I broke up p to the 8th into p to the 6th times p squared, and I pulled out the cube roots of those and got that answer. And then number 10, I pulled out the cube root of 512. I pulled out the cube root of k to the 3rd. I had to break up the g's, and I pulled out the cube root of g to the 99th. All right, let's move on to the next concept.